Yeah. Hello. Am I audible? Hello. Hello. Yeah. Yeah. I hope I'm audible, right?
Yes, sir. Yes, sir.
Okay. So today we'll be discussing about one important concept. It's a little bit difficult to understand as well. So many people told me that it is very difficult to understand. So this is actually called as CRC. Okay. Today we'll be
Okay, sir.
discussing about concept CRC. So
Hmm.
CRC means cyclic redundancy check. Let me just check if I've started the live. Okay. So CRC means cyclic redundancy check.
Yes.
Give me a second.
Perhaps you can repeat.
Yeah. So today we will be discussing about CRC, where CRC means cyclic redundancy check. So I will be showing you the code first. So I will be explaining
Yes.
through code. I'm going to simulation, or else you can go with Jono simulator as well. Yeah. So I just
Hmm.
uploaded one program and I have run the simulation. So if you just check over here, okay,
Hmm.
the first thing that what I have did is I have saved some word like hi for
Yes.
demonstration purpose. I have saved hi into the EEPROM.
Yes.
Okay, and then we generated something which is called as CRC checksum. Okay,
Hmm.
for which we got some value. This is the
Hmm.
hex value. Okay,
Hmm.
hexadecimal value,
Hmm.
and then we have again fetched the data from EEPROM. Okay,
Hmm.
and then see at the time of storing the data inside the EEPROM, not only we are storing this particular high, along with that we are also storing this particular checksum that we generated. Okay,
Hmm.
this checksum is unique for each and every data that you are writing.
Hmm.
Okay, so basically it is something you can just assume like for each and every data that we are storing into the EEPROM, we are generating some unique encrypted thing. Okay,
Mm. Yeah.
so it is not that much of encrypted, it's not that much of secure, but we call it as a checksum. It can be used for validating if the data that we are storing and fetching both
Mm.
are same, or is there or the data got get any corrupted. So this checksum is used for validation if the data that we are fetching is original or got modified or get corrupted. Okay, so we have generated, we have stored word high into the EEPROM, and along with that we have generated this particular checksum which is dependent upon whatever that you are trying to store. This dependent upon that. So we are storing this particular data along with the checksum. We are not only storing high into the EEPROM, we are storing your data along with its encrypted checksum, CRC
Mm.
checksum. And at the time of fetching the data, again we are fetching the usual data that we have stored, and along with that we are also again fetching the stored value.
Mm.
Then what we are doing, we are doing a comparison. If the fetched value, see, here there are two different approaches. The first
Mm.
one is already you have generated one checksum, right? So you can store this pre-generated checksum and you can compare with the stored value. Okay,
Mm.
that's the
Yeah.
one approach. Or else
Yes.
another thing is, already you are fetching the data, right? Again from
Mm.
this particular data, again you can recalculate the checksum. Okay,
Mm.
regenerate the checksum. So
Yeah.
regenerated checksum, is it matching with the stored checksum?
Mm.
Okay, if both are matching, CRC matches, so data is perfect and safe to use.
Mm.
Okay,
Yeah.
so this is the concept of CRC. So CRC means cyclic redundancy check.
Mm.
Okay, so for that there is a huge math. Okay, it is completely related to the math. So here we are having a few data, right?
Mm.
This particular one, this is actually predetermined. So this is
Ah,
common.
okay, okay.
Okay, this is
Okay,
common
okay.
one. It's
Mm.
like an encryption. Okay,
Mm.
so this is common, which we call it as CRC lookup table.
Mm.
So this is provided in some specifications, according to some specifications. So this is the, see, there is also another methods through which we can, without remembering these particular values, we can reconstruct the table mathematically.
Mm.
Okay, through some mathematical operations, by shifting, by doing some shifting operation, we can reconstruct. Okay,
Mm.
there is no need to remember these values. So
Mm.
that thing would be, we will be discussing how to reconstruct a CRC table. That would be explained in a separate session.
Mm.
So as of now, what you need to understand is that this is the pre-calculated. So it is common, no matter whatever you want to store the data. See, this is like the main thing which is used for generating the checksum.
Mm.
So this we call it as CRC lookup table.
Yes.
Okay, this is we call it as CRC lookup table.
Mm.
So yeah. So first, see, already we discussed in the previous session about EEPROM library. Hope you remember.
Yeah, yeah.
In ESP32, we discussed about NVS library, NVS underscore flash and NVS.h. So
Yes.
non-volatile storage, which is equivalent, something like equivalent to NVS. But this is in which we are discussing currently right now is in Arduino module, Arduino Uno.
Mm.
So we discussed very in detail about EEPROM, electrically erasable programmable read-only memory,
Mm.
right?
Yeah.
Yeah. So now this is first we have included the library, EEPROM library, and then we have taken the CRC values. Okay,
Mm.
CRC values, and then, and most importantly, all these integers are unsigned. Okay,
Mm.
these
Yeah.
entire values which are present inside the CRC table, all are unsigned integers,
Mm.
unsigned long. Okay,
Yeah.
so now we will coming to next thing. Now this is the important thing. We are just having the table. This is
Mm.
CRC lookup table. So this table is used to calculate the CRC checksum value. So now what we are working right now is the actual checksum calculation.
Mm.
Okay, so this particular function calculate EEPROM CRC. So this is actually not a predefined function. We are creating this function, user defined.
Mm.
Okay, so by the end of this function, we are having one statement return CRC.
Mm.
Okay, so this will be written in the CRC. But if you just check over here, we are having one symbol,
Mm.
isn't it? So this symbol is used to invert the bits.
Mm.
Any idea about inversion of bits?
We are doing 0 to 1, 1 to 0, right?
Yeah, yeah, right. So let's say, let's assume if we are having something like the output is, let's say if it is, I'm just giving very small 1011. Just assume.
Mm.
So after applying that inversion formula, the output would be 0 1 0 0. So all ones are replaced with zeros and zeros will be replaced with ones. So that
Yes,
is the
sir.
inversion. Okay. So at the end, inversion is taking place. Okay. So now we will see how to generate checksum value with the help of CRC lookup table. Okay, we are not going in detail about how to generate the CRC table through mathematical approach. How to reconstruct the table, that will be dealt in a separate session. It will take around 2 sessions to explain how to reconstruct a CRC table. Yeah. So now we are in discussing about how to calculate EEPROM CRC. Okay. So to calculate that, first we require data size. So that is mandate. Data size is essential parameter. Okay. So let's say you are storing high. So in high we are having two characters. First letter is H and second letter is I.
Yeah.
So each character will be considered as 1 byte. Okay, 1 byte is equal to 8 bits. So total we are having 2 bytes. So here
Yeah.
data size refers to, here the parameter data size refers to number of bytes. Okay.
Yes.
So here data size refers to, I think, yeah, data size refers to number of bytes. Okay. So we are not passing number of bits here. We are the data size refers to number of bytes. Okay. So that means number of characters, in other words, number of see, actually we already discussed that in EEPROM each location can store only 1 byte,
Yes.
isn't it? Each location can store only 1 byte because 8 bits. We already discussed about it.
Yes.
Yeah. So now we have to pass number of bytes. Okay. So let's assume here, see, first we will check this particular code and then we'll go back to the CRC checksum calculation. So first we have initialized the serial library, which is very common just for troubleshooting and printing the output into the serial monitor. So and then we have added one line. So usually many people omit this line. So there is no necessity. So this particular line is used to wait before we really print some value, because serial library also have some latency. So it doesn't immediately start printing the values. Okay, even though you have initialize the serial dot begin, even you fired this particular function begin function. So immediately see print line, what it does not directly print the values. It is having some latency, wait period. So for getting connected to a serial port. So this particular line is used to wait until it is connected to the serial port. Okay. So when serial has been completely initialized, okay, so then we will be printing just a CRC EEPROM CRC demo. Okay, this particular one.
Yes.
And then we have taken two characters. Okay, two characters. So letter 1 and letter 2.
Yeah.
So in letter 1, first character is H and second character is I. So we already discussed that each see, like this 0 and 1 you can have up to 255. Okay. So in each and every character, in each and every location, you can store each and every address, you can store only one character.
Yes.
That is the limit. If you try to store more than one character, it will come under data overflow error. Okay. So if data is less than one character, then that's fine. Data underflow, no issues.
Yes.
Okay. Automatically it can adjust. But if it is greater than uh, 1 byte, then it will come under data overflow error. So now we have stored this first character in one address and letter I in another. This is already we discussed EEPROM.write function. Write function is used to store the data. That's what we discussed in the previous session. Okay, up to here everything is clear. We have just initialized the serial library. Nothing but we have stored two characters in two different addresses.
Yes.
Now this particular function here we are calling calculate EEPROM CRC. Okay, so this function we defined over here. Okay,
Yes.
here now we are passing the value 2. So now that means since we are storing 2 bytes, we are passing 2. If you are storing 3 bytes, you need to pass 3. Okay, depending upon number of characters for you know for whatever the data size you want to calculate the CRC. So you can pass that. Let's say if you pass only 1, CRC will be calculated for only the first character.
That's right.
Okay. So, but here we need to calculate the CRC for entire data that you are storing. So that's why, since you are using two different addresses, so we need to pass the same value. Okay. For how many addresses that you are utilizing, the same number of addresses that should be passed as an integer. Okay. So yeah, we have simply passed the number of addresses that you utilized in the program or by the memory. So when you pass the number 2, this calculated from CRC will automatically calculating the CRC checksum value, and it will be assigning it to the generated CRC.
So we don't have to pass on where is the location. Only that two locations are occupied.
See, actually by default, this program is started calculating the things from
Yeah.
0.
Yeah,
Okay.
this one, yes. Okay, because of that. Okay.
Yeah, see that thing. See, if you want to add more parameters from, let's say you want to calculate CRC from look address A to address B.
Yeah,
Okay,
so we can just
then you
add
can
it
customize
properly.
this particular function. You can make it accept to 2 more parameters,
Got
data
it.
size or else
Location.
yeah, that you can customize. But ultimately, first you need to know how this generation procedure is taking place,
Yes,
how
yes.
we need
Got
to calculate checksum. Then you can customize it as per your requirement. If you want to calculate the data from address A to address B, then you can do that.
Yes.
Yeah, by default here we will be calculating from 0. Okay, that's why here also we have started storing the values from 0. Okay, so but always people don't store values from starting from 0, right? So you
Yeah.
can store values from it any addresses. Let's say you want to store, if you want to obtain the CRC from address A to address B, then you can modify the same function, just a few modifications to this particular one, probably in the this loop function. If for index for int I index equal to 0, right? Here you need to pass, let's say, A. Okay, and index less than data size. So
Then we can pass
yeah,
them and position +1.
yeah. So here you can take 2 more parameters and you can do that. Okay,
Yeah.
then data size is not necessary because you are already passing address A to address B, right?
Yes, yes,
Yeah,
yes.
then data size is not necessary.
Yeah.
Yeah, instead of data size you can pass, you can take 2 parameters and you can modify this particular loop function, and then you can calculate.
Yes.
Yeah, so here we are this function will return the CRC, generated CRC, that will be assigned to this variable. Okay, now see, this is the important thing. uh, Now we are also writing the same CRC in the next thing. Okay, so for first two we have utilized 0 and 1 for storing the actual data. Okay, so the subsequent address, okay, the next address uh, in which we are storing the generated CRC. So there is no necessity that you should store this particular generated CRC in the next available address only. Okay, this is completely for our verification. Okay, the main intention is to generate some checksum value for the original data and store it in the EEPROM itself. Some wherever you want to store in the EEPROM, maybe in at the address which is less than 255, you can store it any wherever you want. Okay,
Yes.
so but if you store it randomly, you may not understand. You may also get confused where the actual data is stored, right? So
Yes, yes.
usually we store it right after the data. We store the generated CRC. That is the standard practice. Yeah. So then we have we have written this generated CRC. Now from the previous session, can you just try to tell me the difference between the write function and put function?
Yeah. So put function. I remember that we did yesterday, right? Read
Yeah,
and
yeah,
write, and we
yeah,
did put and get. Oh,
yeah.
so I think it was in the block,
Okay. Try
and
to.
we can put it like we don't have to go like in the order. Wherever the position is available, it will do that.
So actually, what we discussed is like based on, see, if the data is greater than 1 byte. Okay, we discussed that if you want to store some data which is great, we have taken the example of 4000.
Yes, yes,
Okay,
yes.
if you want to store the number which is greater than 255, then the which they may contain 2 bytes of data
Yes.
or else 4 byte. If you take a floating value, for floats usually it occupies 4 bytes. For integer it occupies 2 bytes. Okay, so then with one function you can you need to split it and store 1 byte because addresses can store only 1 byte.
Mm.
So you need to split the data into segregate into 2 bytes, and 1 byte you need to store in one particular address and another byte you need to store in another address.
Mm. Yes.
Okay, that is when we are dealing with write function.
Mm.
Okay, but when we are coming to put and get functions,
Mm.
so even if the data is greater than occupying more than occupies more space than the 1 byte, it could be 2 bytes, 3 bytes or 4 bytes,
Mm.
it can automatically separate those values into individual bytes, and it can automatically allocate uh, sequential addresses, and it can store the value.
Mm.
Okay, so I hope you can recall from this previous
Yes,
session.
yes, yes, yes.
So now there is a possibility that whatever the CRC that we are generating, it can be, see, it is actually 4 byte. Okay, 4 byte, that means 32 bit.
Mm.
See, if we just check these hexadecimal values, okay, all these are 32 bit integers.
Mm.
So that's why, see, long can we use data type long if you are, if you want to store something like 4 bytes or something like that data. Okay, so all these are 4 byte integers. See, in the CRC table, see, this is the hexadecimal representation.
Yes.
If you convert that into decimal, we will get an integer.
Mm.
Okay, so
Yeah.
which will be having 4 byte.
Mm.
So that means it's a 32 bit integer.
Mm.
So that means if you convert it into binary, it will be having zeros and ones like 2 power 32,
Yes.
isn't it?
Yeah.
Yeah. So for this generated CRC, it is it occupies 4 bytes.
Mm.
So that's why if you use write function, it will become overflow error.
Mm.
It cannot, because it can store only 1 byte. So that means, so that's why we need to use CRC. I mean put function.
Mm.
So see here what actually happening. You are thinking that we have kept this generated CRC at position number 2, address number 2.
Mm.
But actually generated CRC is stored in address 2, address 3, address 4 and address 5.
Mm.
Because it is a 4 byte 32 bit 32 bit integer.
Yes.
So that means 4 bytes. Okay, because each byte means 8 bits. So
Yes.
4 8 32. 4 bytes it is having 4 bytes. So it will be splitting, automatically splitting into 4 individual bytes, and each byte is stored in corresponding, starting from 2, it keep on incrementing the values. Okay,
Mm.
address values until the entire data is stored completely.
Mm.
So yeah, that's what we described over here, 2 3 4
Yes.
5. So that means again, if you want to store next data, so that you need to store in address number 6.
Yes, sir.
Okay, because if you are storing the data, then you know how much of space it is occupying in the EEPROM.
Yes, sir.
If you know the size of the data that you are storing in the EEPROM, then you know that how much of space is required for CRC,
Yes, sir.
isn't it?
Yes, sir.
Yeah, by default, whatever the data that you're trying to provide, it will be converted into 4 byte CRC only. Even if you try to give even more number of, see here we have utilized only 2 addresses. Even if you take more addresses, the
Mm.
output of the CRC would always be 4 byte.
Mm.
Okay. Yeah. So here we have generated the CRC, and we have kept, stored that CRC into in the EEPROM, and then again here we are using the read function. There we used write function, here we are using read function.
Mm.
Okay, but again remember, here we are using put function for storing the checksum. Again, to get the value also you need to use get function, not read
Yes.
function,
Yeah. Yeah.
because you need to read the values from 4 subsequent addresses, right?
Yes.
So if you use read, it can read only from the that particular address. It don't
Mm.
care about the whether the data has been splitted into multiple fragments, multiple bytes, and stored in each individual address. It will not be able to recognize that.
Yes.
Only get can recognize it. So again, see, by up to here we have already stored the original data, and we have generated the checksum, and
Mm.
that checksum we have kept, we have stored it in the EEPROM.
Mm.
And then again here now we are trying to fetch our actual value from the 2 different addresses from
Mm.
where we actually stored the values, and then we have taken an empty variable,
Mm.
unsigned long. We already discussed that all are unsigned integers. Okay,
Mm.
we are using the data type long because it is 32 bit. Okay, it is occupying 4 bytes of memory.
Yes.
And then EEPROM dot get. So again we are trying to get the stored CRC,
Mhm.
and then here we are trying to recalculate the CRC. Here there are two approaches. When you generated the checksum, you can store that checksum in one particular variable. Okay, you can compare this generated CRC with this fetched CRC. Okay,
Yes.
uh, yeah, here you can take one more variable. This is generated CRC, right? Yeah, you can compare the generated CRC with the stored CRC. Okay, or else the another approach is again you can recalculate the CRC, which is the safest practice.
Yes.
Okay, so again we will be doing the again we are recalculating the CRC from the same data that we have read.
Mhm.
Okay, so that will be considered as the native CRC. So now we are comparing this native CRC with the stored CRC, if both are
Mhm.
matching or not. If
Mhm.
both are matching, then whatever the data that we have stored is uncorrupted. Okay, is in the original form.
Yes.
Okay, if there's any, if the CRC is a mismatch, then data has been corrupted.
Yes. Fine.
So just give me a second, I will explain you this particular one. I need to
Sir,
plug in the charger. Give me.
yeah. Sir, I have 4 o'clock class, sir. Can I please leave now?
Okay, okay, sure.
Yeah,
So shall
okay.
we discuss about generation, about this
Later.
particular,
Yeah.
yeah,
Next time.
mechanism of generating CRC
Yeah.
tomorrow?
Next time we can do that, please.
Okay, okay, sure, sure.
Or you can continue the class. I can join the recording afterwards.
Yeah, yeah, no issues, no issues. I do have
Okay. Sorry
other.
about it.
Yeah, thank you.
Thank you, sir.